Welcome back to NTMAU. This problem is Advanced Math 320-127. And what we're going to do is we're going to begin with trying to solve whatever angles, again, as usual, to solve that we can possibly solve. I'm going to start right here at this 60 degrees because, you know what, it's there, it's easy, it's already got an angle on it. Could probably find a height relatively simple. Keep in mind though, when you solve for these problems, you have to come to tangent points. So most likely what I'm going to do is I'm going to take and subtract this ½ inch. I'm going to and I won't have to subtract anything else, but I will subtract this ½ inch radius here from this overall length to give me an arc from this point down and over. And we'll go from there. Okay, so I'm going to sketch it up, see where we go from the very beginning and the starting point. Other angles that we're going to come into play, they're going to be all over the place on this thing. One of the ones we'll probably have to draw something from this point to this point to this point, come up with possibly the law of sines, law of cosines. Don't know yet. Another point that you might find is coming straight across here, straight down and back up. Well, of course, this is x that they're looking for, so that's something that we're going to come up with. So straight across, down, and over. Hey, we got to try to work in that direction there. Another one that we come up with, well, who knows? But we're going to break this down step by step and go from there. All right, here we go. Let's begin. Okay, so I have several angles that I've put in here. Now the thing that we know is this distance from here to here is going to be parallel this whole way up. That's why I have this solid. So we have a ½ inch radius here, and we have a ½ inch radius here. We know this 60 degrees is going to stay constant. It's going to stay continuous throughout the whole thing. So we've got 60 degrees inside here, and we have 60 degrees inside this little green angle inside here. In addition, we have 60 degrees inside this over here. So we have a whole bunch of things that we can solve for here. The first one we're going to do is we know that we've got a distance from this point to this point of 2 inches, 250 thousandths. How did we get that? Well, we know that we've got a ½ inch from here to here, all right? And if we have the 2 inches, 750 thousandths, and we subtract this ½ inch, we come up with the 2.25. Okay, so let me sketch that up for you and let me show you how those numbers work. So here's the math on that. We know that we've got 2 inches 750 minus the 500 thousandths. That gives us the 2 inches 250 thousandths. That's the distance from here to here. If we solve for this side right here, which is the adjacent side, we're going to come up with a 1 inch 299 thousandths. Okay, so let's just keep that in mind, mark that down. So again, if you're looking for the adjacent side, when you have the opposite side, because that's opposite, okay, we're going to solve for the adjacent over the opposite side. And we'll come up with this surface here. Okay, go ahead and do the math. You'll see that this is right. Then I'm going to put in this green angle over here, this one right here. And with this one, what I want to do is I want to look for the no, wait, I'm going to do this angle here first because I've got this one over here. So let's do this one here first. I'm going to look for the adjacent side. This is 60 degrees inside here, all right? So I'm going to just kind of take this in order. So that's 60 degrees. And I know that I have, what, a ½ inch distance from here to here, right? Because this radius, this ½ inch radius, although I've got it all marked up over here, but this ½ inch radius or this ½ inch height here remains the same or remains consistent all the way across. So if this is ½ inch here, and this is the adjacent side that I'm looking for, adjacent over the opposite equals the cotangent. The cotangent of 60 degrees is 577/5/10. All I'm going to do is take a ½ inch and multiply it times the 577/5/10. And I will come up with this distance from here to here, which is the 288 7/10. All right? Mark that one down. Now let's solve for the hypotenuse. I'm going to bring it over to this one here. That's where I was going to start before, but now I'm going to put it into this green angle. All right, doesn't matter which one of these you do first, but irregardless, I'm just kind of moving in this direction. All right, so back to this one. This green triangle. I know that my distance from here to here is a ½ inch. So put the ½ inch down. What is that side going to be? Well, again, here's your 60-degree angle inside here, right here. Right? If that's your 60-degree angle, what's this distance over here? This distance is the opposite side, right? So if this is the opposite side and you're looking for the longest side, which is the hypotenuse, remember your 90 degrees is going to stay consistent here. So you're looking for the hypotenuse and you have the opposite. That's going to be the cosecant. You use a cosecant. So hypotenuse over opposite equals cosecant. So go 60 degrees, hit your cosecant key. You're going to come up with the cosecant of 60 degrees as being 1.1547 times the half inch. That's going to give us this 577 and 3/10. That's this distance right here. I've got this as 4. If you figure it out as 4 is 3. It actually comes out to 577 and I think 3 and 8 half-tenths or whatever you would call that out at that point. All right. So then what we're going to do is subtract everything. We have the 3 inches, 750 thousandths, which is the distance from here all the way over to the end, minus this, and minus this. So 3 inches, 750 thousandths, minus the 1 inch, 299, minus the 288 and 7/10. That's this distance right here, or this one here. Okay. And minus this distance right here, which is the 577.4. Okay. You're going to come up with somewhere around 1 inch, 585 and 1/10. What is that? That's the distance from this point here over to the center line of this point here. All right. So I'm going to get rid of all of my math numbers here. I'll leave the dimensions in, but I'll get rid of all the sketches that you've got going on here. And we're going to create one more triangle inside here, and that's going to be the distance from here to here, which is going to remain at the 1.5851. All right, mark that down. That's going to be what we get from here to here by taking all of these and subtracting it from this. Again, we have this minus this minus this minus this. So 3 inches 750 minus 288 and 7/10 minus 577 4/10 minus 1 inch 299. Okay, and we figured those all out using that same 60 degrees. Okay, I'll pause, clean this up, and we'll. All right, so what I've done now is I'm going to take a squared, 1.5849, 1 inch, 584 9/10, plus b squared, 2 inches, 250 thousandths, and that's going to equal c squared, which is going to be 2.7522. So if you remember how to do this, you're just going to go a squared, which is, just plug this into your calculator. In fact, let me sketch it out here for you. Okay, so 1.589, hit this key right here, this square key. Should remember this, but just because it's been a while since we've done that, I'm just going to kind of review it for you. And then just hit the plus key, and then 2.25, hit this key again. Then hit the equal sign, and then hit the square root key. You're going to come up with this distance here of 2 inches, 752 and 2/10. Now what I'm going to do is I'm going to connect this and this to this center point way up here, and I'm going to bisect this angle. So I know that I've got this distance here in here now. I'm going to connect it to this, I'm going to connect it to this, and we're going to keep on moving forward. So let's take a look at that. I'm going to pause this, clean this mess up over here, write this down, make sure that you've got it, and we'll move forward. Okay, so what I've done is now I've bisected this angle, the 2.7522, to be half. So it's bisected off this green piece here. So we see this here. And what I did is I took 2.7522 divided by 2, and I come up with 1 inch, 376 and 1/10. So that's the distance from here to here. Now, what do I know? I know that the distance from this point up to here has to be 4 inches, because this is 3.5 inches from here to here, because it said that that's what our radius was. And we're adding a 1/2 inch onto here for this radius. So if this radius here is a 1/2 inch, and this radius coming from the center point is 3.5 inches, that's 4 inches total. We now have two sides. We have a squared, which is this, the 1.3761, that's right here, and the 4. So I can solve for this angle inside here. So I come up by doing that, and I come up with the 69.880 degrees decimal degrees. Okay? All right, let's take a look and move on from there. Okay, so we bisected this. We came up with this distance here. Okay? And then what we want to do is we want to figure out what this angle is here. Now, when I know what this triangle is inside here, I know that I had the 1.3761 and I have 4 inches. So I can solve for this angle. This is the hypotenuse, okay? And this is the adjacent side. So adjacent over hypotenuse, you could then solve for this. And we want to then solve for this angle. We knew that we had the 2.25 here, and we know that we have the 1.584 and 9/10 here. So solve for this angle, and you're going to come up with 35.1619. All right. So 69.880 from here to here. That's right here. Got that one right here. Okay. And the 35.1619 equals 102.009. Now it's easy. All we have to do is take the 180 degrees that comes all the way around this whole surface here, this whole thing here, and subtract the 102 and 9 thousandths, okay? You're going to come up with a distance inside here of 74.9581 degrees decimal degrees. So that's what this angle is here. And guess what? You can solve the rest of this thing real nice and easy because you know this is 74 degrees, 0.958 and 1/10. You know this is 4 inches from here to here. I'm going to create one last triangle inside here. And voila, you'll not only have the X, but you'll also have the Y. I'm sorry, you'll have the X and you'll have the Y. All right? You'll have both. All right, so I'm going to sketch that up real quick. Let you see what that looks like, and you should be able to bring it home from there. Okay, so bringing it all home, we know that we've got 74 degrees, 0.958 decimal degrees. That's this inside here. And again, we got that because we also knew that this angle inside here was 35.161 and 9/10 of a degree. So let's put this down here, 35.1619 degrees, decimal degrees. Take this whole thing, subtract it from 180. Take this and this, subtract it from 180. We get to 74.9581. And then we know that we've got 4 inches from here to here because we had a 3 inches, 500 thousandths radius up to this point. And then we're adding a ½ an inch onto this radius here. So now what we have is we're looking for the adjacent side. When you do that, to solve for y, we're going to get y as being 728 and 2/10. Okay, that's going to give us the distance from here to here. Simple to find x. Finding x, just take c squared minus b squared equals a squared, and voila, there you have it. Hope you kind of understood this. I know it's very complex. I hope that adding the colors in here made it a little bit easier for you to understand. And if you have any questions, please review the drawing once more, the whole math problem. Take it step by step. Don't try to do too much at one time. And if you still run into a problem, give me a call and I'll try to work it through with you. Okay, thanks, and you have a great day. Take care.